All right, this is a quick demo about the new auditing capabilities that we have introduced to Spike. The feature is pretty new. We just pushed it like 10 minutes ago, I guess, in the main branch. So instead of explaining how things go, it's better to show as usual. So let me open up the terminal and go through the process of initializing Spiffy, Spire, and Spike. So before everything, I'll just clear my tabs and terminals so that I can start with a blank, clean slate. As usual, if you have been following the former demos, I will start by initializing a Spire server, which will also build Spike binaries for me. And then I'll create a Spire agent. And Spike components will talk to Spire agent to get SVITs. And SVITs are certificates to help Spike establish MTLS. And Spike has two components as part of the secret store. One of them is Nexus, and the other is Keeper. I'll start them so we can have a secret store to push secrets to, essentially. I'll start Nexus and then I'll start Keeper. And now let me clear this one as well. Let me initialize Spike. It will ask me for a password. I have a really secure password down here that I can use. I'll just copy it. Kidding, this is not secure at all. And as usual, you are highly encouraged to use a secure password and use a password manager to store those passwords instead of sharing them in plain text. So let me go back. I'll paste the password. I'll paste it again. And then I will log into the system using Spike login command. It will ask for my password. I'll enter the password again. And now I have a short-lived JWT token, JSON Web Token. So if I search for it, it is here, Spike admin token. It's down here. So I can just give me a second. Yeah, it's down here. Spike admin token, and if I cat that one, cat Spike admin token, let me clear this one. You can see that it is like a JSON Web Token. So let me clear this and execute some actions to show how the audit trails happen. I'll clear this one. Let's create a secret, for example, Spike, or let's get a secret. Spike get tenants Acme DB. Enter. It will say secret not found, but what's interesting in this exercise is the logs behind the scene. So while doing that, it created a unique trail ID for us. This OINJ5PCR is a trail ID that we can follow, and that trail is the trail of the get secret command that we said. So these two kind of create a track record of what has been happening. So it will be useful to audit things, and if something happens, we can check those logs and see, what has been happened behind the scenes on the system, which is good for security and accountability and auditability. So what is happening is, it first enters the trail. We see which API path that has been executing, and also we have a state which says created, and the second trail we have a state that says success, and other than that it's the same path, and most of the other information is same as well. And we also have a duration here, so we from the start and the end of the action we know how much time has passed, so that can be useful for like monitoring, diagnostic, application performance improvement, and those kinds of stuff as well. But this is like the trail log that we have, and of course there's room for improvement. For example, this session ID is blank. The user identifier user ID is also blank here. And another area of improvement is these trails. Excuse me. These trails are being entered on the standard output stream. So ideally, the application logs and audit trails should be separated as per security best practices. And again, ideally, we should have a way to push these logs to a secure log aggregator or a secure logging server. So those are things that are essentially doable, because like entire logging, entire auditing flow of Spike is centralized. So we have this central route handler that all of the API methods of Spike Keeper and Spike Nexus inherit, and that centralized logger does a bunch of things. One of them is to create two audit entries, like one during the entering the API action, and second while it exits the API action. And we have this audit trail entry that we initially create, and you see, not that one, sorry, this one, this audit entry is a pointer type. So that's that means we pass and also we pass the audit entry to our handler, which means inside the API methods, we can enrich this entry as well if we want to. Right now we don't, but we have the capability to do so as well if there's a need for that. But essentially, aside from those, after we execute this API action, we either exit successfully or we have an error, like an authentication error or some other kind of an internal server error. And if there is no error, we set the audit trails state to success. Otherwise, if there's an error, we set it to errored, and we also add that error to the audit trail as well. To emulate that, I will show you how I can emulate it. Essentially, I can just change the Spike admin token, temper it so that my authentication will fail, and I'll have an audit trail about that, like somebody tried to authenticate but that authentication failed, which will be useful for our InfoSec people and sysadmins, because it might raise an alert and then they can look into the issue essentially. So let me enter my command. It says unauthorized, please log in first with Spike login, because like my token is invalid essentially. But as in terms of auditing, we have another unique trail ID, and these trail IDs are generated uniquely at every HTTP request, so that we can filter things by ID. If I grab for this ID, I'll only see this trail that's related to this entry. And this log is structured, say JSON structured logging format, so it will be easy to export things essentially. But aside from that, what's more important is like what's happened in this case, like when it failed. So we read after initialization of the trail, we try to read a secret from this path, and now we have an error state, and we also have a description of the error, which says invalid or missing JWT token, which is T stands for token anyway. It shouldn't be, we can just say JWT, but still, aside from the typo or nomenclature, we have a detailed error message that we keep for our logs, and we don't reflect this to the end user. The end user just gets the message saying, hey, can you please authenticate? The details are for our system personnel essentially, or DevSecOps. And we also have this duration here as well. But yeah, that's, as I said, that's the initial take at how we can do audit trails in Spike. and your contributions are always welcome. If you have ideas to enhance this functionality, or if you want to add value to do some well-known log aggregator integration, you are more than welcome to come and join us. You can create an issue. You can open up a discussion in Spiffy Slack. We will be more than happy to have you on board and have you contribute to this project. But as far as aggregating logs, or as far as auditing logs and creating a audit trail of logs goes, that's all I have. Until next demo, keep your secrets secret.